This video shows you how to multiply a decimal fraction by a single-digit whole number and estimate to check. Essentially, this is the same concept as the previous lesson, but we're estimating to see where we're going to put the decimal. We have a problem, 31 times 4. Before we solve it, we can round to a close number so that we can see approximately where our solution should be. If I were to solve this, I would put 31 to 30, and I can keep 4 the same. So I have 30 times 4, which I can do 3 tens times 4, which is 12 tens, which is the same as 120. So I know that my solution should be pretty close to 120. So when I solve it, I can use the regular algorithm, which is 31 times 4. 4 times 1 is 4. 4 times 3 tens is 12 tens for 124, which is pretty close. I can also solve this using the area model. Okay, when I do that, I have my rectangle again, put 30 on top, or 3 tens, 1, multiply it by 4. 4 times 3 tens, or 4 times 30 is 120. 4 times 1 is 4. 120 plus 4 is 124. The idea here is we want to make sure that we are in that same ballpark. Using that same idea, we can solve the problem 3 1/10 times 4. Again, when I solve this one, I would round 3 1/10 to 3 and multiply it by 4, which gives me 12. So it should be about 12. Now, when we use the area model to solve this, we want to make sure that we include the whole number and the decimal. A lot of people like to just leave off the decimal and do only the first part. That's only halfway. Make sure that you include the whole number. Okay. When we solve this, we have 4 times 3, which is 12. 4 times 1/10, which is 4 tenths. And I can add 12 plus 4 tenths, which gives me 12 4 tenths. And then I can check that I did my work correctly using the standard algorithm of 3 1/10 times 4. 4 times 1/10 is 4 tenths. Bring down the decimal. 4 times 3 ones is 12 ones, or 12 4 tenths. What I want to do then is check and make sure that I did move down the decimal correctly, where I have 12 here, and 12 is my estimate. Okay. I could have also rounded 3 1/10 to maybe 5, which would have given me 5 times 4, which is 20, which is still in the general ballpark, opposed to having 1 24 hundredths or 124. Try this problem on your own. 5 1/10 times 6. Estimate first and then solve. When I solved this using the standard algorithm and using the area model, I found that I have my solution as 30 6/10. 30 6/10 is still in the same ballpark as my estimate of 30, noting that when I estimated 5 1/10, I moved it down to a 5 and kept the 6 to multiply 5 times 6 to get 30. Try one more on your own. 11 4 tenths times 4. When I solved this, I rounded 11 4 tenths to 11, multiplied it by 4 to have an estimate of 44. Solving both with the algorithm and the area model, I had 45 6 tenths as my product. And while 45 6 tenths is not as precise as 44, it is in the general ballpark. It's telling me where I need to put the decimal place, so it's close to where I need it to be.